Hi everyone. So this is question number 4. The question says, it takes a golfer a total of 3 strokes to put the ball in a hole. The displacements of the 3 strokes are as follows. D1, 3.9 meters due north, D2, 2.2 meters northeast, and D3 equals 0.9 meters at 30 degrees west of south as shown in the figure. If the golfer had made the hole in a single shot, what would be the displacement of the ball? So everybody, the problem gives you, write down the given information, 3 displacement vectors of the ball. So it goes in the north direction, then it goes northeast, and then 30 degrees west of south, which we will come to in a second, right? So the ball undergoes 3 displacement vectors. Now the question is, if the golfer had made the hole in a single shot means what? It means starting from the starting point all the way up to the hole, right there. This is the vector in question. This is the vector in question, right? Basically, this is the net displacement, right? The displacement of the ball, the distance from the starting point to the final point. But in vectors, we say this is the resultant vector R, which is a summation of the first displacement vector, second displacement vector, and the third displacement vector. So far, so good. Where do you start? You write down the given information. The first displacement vector, you have to write down its length, and you have to put down the angle. What is the angle? Right, the angle means it's pointing to north. North means 90 degrees. So let's just go here. We have the north, the south, the east, and the west. 90 degree, this angle here is the north, right, which corresponds to 90 degrees. So you have to write down the corresponding angle. The second displacement vector tells you what? 2.2 meters, write it down, and the angle is northeast. North of east. What is that angle? Northeast is 45 degrees. On the day of the exam, the angles will be given to you explicitly. And finally, the third displacement vector, 30 degrees west of south. West of south. So everybody, the reference is given to you in terms of south, right? Then you go 30 degrees west of south. 30 degrees west of south. This is the west, that's the south. You are going 30 degrees west of south. The angle is 30, that's good to know, but that's not how we measure the angle. We have to be consistent. If you choose a single reference line to be your reference to measure the angle, you have to be consistent. What does that mean? You choose the positive x-axis as the 0 degree, then you go counterclockwise, you have 90 degrees, plus you go 90, plus, what is this angle? 90 minus 30. That's going to give you right here. Now what? You add 90 plus 90, 180, plus, what is 90 minus 30? That's going to give you 60. What is 180 plus 60? That's going to give you 240 degrees. 240 degrees. If you got the problem incorrect, I'm sure this was the issue, figuring out the angle with respect to the chosen reference line. So far, so good? Good. What's the next step? You are calculating the resultant vector the summation of the first, the second, and the third displacement vectors, right? What are we trying to figure out again? We're trying to figure out this length here. This vector, its magnitude, and the direction. So far, so good. Now, we have 3 arbitrary vectors that point in arbitrary directions. So how do you add those vectors? The first step you should be doing is resolving each vector into its horizontal and vertical components. You take the first vector, you resolve it into its horizontal component. You take the vector times cosine of the angle. Then you take the second vector, you take the vector times cosine of the angle. The third vector, you resolve it into its component. You take the third vector times cosine of its angle, right? I'm not going to do all of these steps one by one. You should just do them by yourselves. This line here is the summation of all the vectors pointing in the x direction. And I'm getting myself 1.106 meters. How many significant figures do you have to use? I don't care. Just give me some number. As long as you give me a few digits, right? Good. Moving on. You do the same thing with the vertical components. What do? You sum up all the vertical components. How do you find a vertical component? For the first vector, you take the vector times sine of the angle. Second vector, you take the vector times sine of the angle. The third vector, you take the vector times sine of the angle, and you get yourself the summation of all the vectors in the vertical direction. Now that you have found the resultant vector in the x direction, the resultant vector in the y direction, you want to go and figure out the resultant vector. How do you do that? You take r sub x, the horizontal component square, the vertical component square, you take the square root. You're basically doing Pythagorean theorem, right? Continue, you take the square root, right? 4.805, the textbook WebAssign rounds it off to 4.81 meters. There you go. That is your resultant vector. What did we just figure out, everybody? We just figured out the distance between the starting point all the way to this hole. If you were to get the ball into the hole in a single shot. Finally, we are asked to determine the angle. How do you find the angle, everybody? If you are given the resultant vector, you are given the horizontal component 1 meters, you are given the vertical component 4.6 meters. How do you find the actual displacement vector itself, the resultant vector itself? Right here, you're trying to figure out the angle. Arctangent, the vertical component divided by the horizontal component, right? Plug in and you get 76.7 degrees. 76.7 degrees north of east. So you can see here my figure here, the vector shown in this figure is consistent with the vector that you are seeing here. And what angle did we just find out? We just found out this angle here, 76.7 degrees. Let me zoom out. If you want to take pictures, we can take pictures.